Anticipated growth in space exploration, telecommunications, and robotics industries due to Mars mission advancements by Q4 2032. Date of report, January 25, 2025. Event overview. This report outlines the expected 50% growth in the space exploration, telecommunications, and robotics industries by the end of Q4 2032, driven by advancements in Mars missions and the development of space robotics technologies. Summary of key insights. The anticipated growth is primarily a result of several converging factors. 1. Transformative role of space robotics. Companies like MDA Ltd and Airbus are innovating in the field of space robotics, which is becoming crucial for tasks that are dangerous or impractical for human astronauts. These advancements include spacecraft inspection, satellite servicing, and debris collection, all of which enhance mission safety and sustainability. 2. Synergistic development of missions. The overlap between lunar missions such as Titan Space's Selene mission and the upcoming crewed Mars mission, 2032, highlights the interconnectedness of technology and resource utilization. Innovations in lunar habitats are expected to influence Martian designs, facilitating a more efficient approach to resource use across both celestial bodies. 3. Technological innovations. The integration of robotics and artificial intelligence is vital for enhancing mission efficiency. Advanced AI systems are expected to automate complex tasks, reducing risks and allowing human crews to focus on exploration. The development of nuclear propulsion promises to expedite travel to Mars, improving safety and mission feasibility. 4. Investment and growth projections. Significant investments from both private and governmental sectors are fueling growth in these industries. The increase in patent applications in robotics indicates a robust innovation landscape, with companies and nations actively investing in technologies for lunar and Martian exploration. Timeline of key events. 2024, initial advancements in space robotics are reported, indicating a surge in innovation. 2025, the Selene mission is officially initiated, emphasizing sustainable lunar exploration and resource utilization. 2030, preparations for the crewed Mars mission commence, leveraging insights gained from lunar missions. 2032, expected completion of key technological milestones, marking a significant growth trajectory for the space exploration sector. Detailed insights from sources. Source 1, Space Robotics Market Analysis. The report from Global Data emphasizes the rapid innovation in space robotics, with the focus on the following applications. Spacecraft inspection, utilizing robotics for thorough checks of spacecraft integrity. Satellite servicing, extending the life of satellites through robotic maintenance. Debris collection, addressing the growing issue of space debris with autonomous systems. Leading companies in this field are advancing technologies that will not only enhance mission capabilities but also contribute to the sustainability of space operations. Source 2, Evolution of Space Robotics. This source outlines how robotics is transforming space exploration. Key points include: autonomous systems, robots are being developed to perform tasks on the Moon and Mars, including habitat construction and resource extraction. Collaboration with AI, the integration of AI enhances the capabilities of robotic systems, facilitating more complex operations without direct human control. The report also discusses the role of space robotics in enhancing telecommunications, particularly the deployment of satellite constellations like SpaceX's Starlink. Source 3, Strategic overlaps between missions. The analysis from Titan Space highlights the strategic overlaps in their Selene and crewed Mars missions. Technological development, insights from lunar missions will inform Martian technology, particularly in life support and habitat construction. Resource utilization, both missions prioritize the use of local resources, with methodologies being adaptable across both environments. International collaboration is emphasized as a critical factor in achieving the ambitious goals of these missions. Conclusion. The anticipated 50% growth in the space exploration, telecommunications, and robotics industries by Q4 2032 is driven by significant advancements in Mars missions, the transformative role of space robotics, and extensive collaboration between various stakeholders. The synergistic relationship between lunar and Martian exploration efforts will not only enhance technological innovation but also facilitate sustainable practices that redefine human capabilities in space exploration. As we move forward, the integration of robotics and AI, coupled with substantial investments and international cooperation, will pave the way for a new era in space exploration, ultimately expanding humanity's reach in the cosmos. This report has synthesized the most critical aspects of the anticipated growth in the space sector, highlighting the interconnections between robotics exploration missions and technological advancements that will shape the future of human endeavors beyond Earth. The anticipated 50% growth in the space exploration, telecommunications, and robotics industries by Q4 2032 due to advancements from Mars mission developments presents several counterintuitive insights. 1. Dependency on robotics for human safety. While one might assume that the primary focus of space missions is human exploration, the growth in these industries is significantly driven by the increased reliance on robotics. Robotics are increasingly seen as essential for safety and efficiency, handling tasks deemed too risky for human astronauts. This shifts the narrative from human-centric missions to a more robotic-focused approach where machines are paving the way for human exploration. 2. Lunar missions informing Martian exploration. It might seem logical to assume that missions to Mars would primarily focus on Martian technologies and conditions. However, advancements from lunar missions, especially the Selene mission, are expected to inform and enhance Martian habitats and technologies. This interconnectedness suggests that exploration of the Moon is not just a stepping stone but a vital contributor to the success of long-term Mars exploration, challenging the perception of lunar missions as secondary. 3. Economic growth from space robotics. The expectation that the growth in space robotics will directly lead to advancements in telecommunications and other sectors might seem far-fetched. Yet the integration of robotics in satellite servicing, debris collection, and the development of satellite constellations is projected to significantly boost the telecommunications sector. This indicates that growth in space exploration has a ripple effect, enhancing other industries rather than standing alone as a niche market. 4. Investment trends. A common assumption might be that government funding is the primary source of investment in space exploration. However, the data suggests a growing trend of private sector investment, indicating that commercial interests are driving innovation and growth. This shift in investment dynamics challenges the traditional view of space exploration being a primarily governmental endeavor. 5. AI and robotics in space. The role of AI in enhancing robotic capabilities might seem like a straightforward technological advancement. However, the intricate ways that AI can reduce costs and improve efficacy in both space exploration and terrestrial applications highlight a more complex relationship. The advancements in space robotics are poised to bring back substantial benefits to Earth, contradicting the belief that space technologies are isolated from everyday life. 6. Interplanetary resource utilization. The notion that resources will need to be brought from Earth for space missions is quickly evolving. The emphasis on in-situ resource utilization (ISRU) for both lunar and Martian missions demonstrates a shift toward sustainability and self-sufficiency in space. This challenges the long-held belief that space exploration will always be reliant on Earth-based resources, suggesting a more autonomous future. 7. Technological overlaps. The synergies identified between lunar and Martian exploration missions indicate that technologies developed for one can significantly benefit the other. This interconnectedness reveals the counterintuitive idea that separate missions can share technologies, strategies, and resources, creating a more collaborative and efficient approach to space exploration than previously imagined. 8. Global collaboration. The belief that space exploration is primarily a race among nations is being challenged by the increasing emphasis on international collaboration. Initiatives like the Artemis Accords and various international working groups for lunar and Martian exploration show that the future of space exploration may rely heavily on cooperative efforts rather than competitive ones. 9. Robotics in space tourism and colonization. The idea that robotics will play a significant role in space tourism and colonization may seem surprising. However, the necessity of robotic technologies for constructing habitats and managing resources for human visitors highlights a future where tourism is supported by robotics, indicating that the human experience in space will be heavily mediated by machines. 10. Public-private partnerships. The expectation that public space agencies will dominate space exploration is contradicted by the increasing importance of private companies. The collaboration between public and private sectors not only enhances funding but also accelerates technological advancements, indicating a shift in how space exploration is approached and funded. In summary, the anticipated growth in these sectors is not merely a straightforward trajectory based on human exploration but is instead a complex interplay of robotics, international collaboration, and innovative technologies that are reshaping our understanding of space exploration's future. The anticipated 50% growth in the space exploration, telecommunications, and robotics industries by Q4 2032 due to advancements from Mars missions is both exciting and significant. But certain aspects may be overlooked by the general public. Here are key points that hold importance beyond the surface-level understanding of this growth. 1. The role of space robotics in safety and efficiency. While many may acknowledge the role of robotics in space exploration, the depth of its significance often goes unnoticed. The report highlights that robotics enables the execution of hazardous tasks that are too dangerous for humans, such as debris collection and spacecraft repair. This is not merely about convenience, it's about survival and mission success. As we venture further into space, the risks associated with human presence increase exponentially. The integration of autonomous systems, as mentioned in the report, can significantly reduce the potential for human error and enhance the safety of missions. For example, NASA's use of autonomous robots for constructing habitats on the Moon and Mars is a critical step towards ensuring that human crews can focus on exploration rather than basic survival tasks. This shift towards robotics not only enhances safety but also promotes more complex mission objectives, enabling unprecedented scientific research. 2. Synergy between lunar and Martian missions. Another aspect that may be overlooked is the interconnectedness of lunar and Martian missions, particularly how advancements in one area can significantly influence the other. The report outlines how technologies developed for the Selene mission lunar can inform and enhance the crewed Mars mission. This synergy implies a strategic approach to space exploration where investments in lunar missions can yield benefits for Martian exploration, thus optimizing resource allocation and reducing costs. For instance, in situ resource utilization (ISRU) technologies developed for extracting water from lunar ice can be adapted for use on Mars. This cross-pollination of ideas and technologies not only accelerates progress but also fosters a more sustainable approach to exploration. The significance of this synergy lies in its potential to create a robust infrastructure that can support long-term human presence on both the Moon and Mars, ultimately paving the way for future interplanetary endeavors. 3. Economic implications and investment trends. The report indicates substantial investments from both private sectors and government agencies, which often go underappreciated in discussions about space exploration. The anticipated growth of 50% is not just about technological advancements, it reflects a burgeoning sector that is increasingly attractive to investors. The growth in patent applications for robotics indicates a robust innovation landscape, suggesting that countries and companies are racing to secure their positions in this emerging market. This investment trend is significant because it not only drives technological advancement but also creates jobs, stimulates economic growth, and fosters international competition and collaboration. The implications of this economic shift extend beyond the space industry, potentially influencing sectors such as telecommunications, manufacturing, and artificial intelligence. 4. Global collaboration and its importance. The report emphasizes the importance of collaboration between private companies and governmental space agencies, which is a critical point that may be overlooked. As missions to Mars and the Moon become increasingly complex and costly, the need for global collaboration becomes paramount. International partnerships can lead to shared resources, knowledge exchange, and reduced risks associated with space missions. This collaborative spirit could also foster goodwill among nations. Transcending geopolitical tensions. The significance of this collaboration lies in its potential to unify humanity's efforts in exploring space, making it a shared endeavor rather than a solitary race among nations. 5. Technological innovations beyond space exploration. Many people may not realize that the technological innovations arising from space exploration, particularly in robotics and AI, have far-reaching implications on Earth. For example, advancements in AI-driven robotics initially developed for space missions can be adapted for various applications, including disaster response, automation in manufacturing, and even healthcare. The report mentions that robotics can assist in satellite maintenance and repair, which can extend the life of satellites and improve global communication services. This not only has economic implications but also societal ones, as improved communication can facilitate better access to information and services globally, particularly in underserved regions. 6. Long-term impacts on human exploration. Finally, the long-term vision of human exploration and colonization of Mars may be met with skepticism, yet it represents a significant leap for humanity. The report discusses the potential for Mars to become a second home for humans, which, while aspirational, is a reflection of our innate drive to explore and expand our horizons. The significance of this vision lies in the potential benefits for Earth, including technological advancements, resource utilization, and new scientific discoveries that could enhance our understanding of life and the universe. Moreover, the psychological and philosophical implications of becoming a multiplanetary species could redefine humanity's place in the cosmos and inspire future generations. Conclusion. The anticipated growth in the space exploration, telecommunications, and robotics industries due to Mars mission advancements is a multifaceted phenomenon that extends beyond economic statistics. Key insights regarding safety through robotics: synergy between lunar and Martian missions. The importance of global collaboration and the far-reaching impacts of technological advancements showcase the depth of significance behind this growth. Recognizing these aspects can foster a more profound appreciation for the advancements in space exploration and their implications for humanity's future. 1. Space robotics as a game-changer. The transformative role of space robotics is critical in revolutionizing exploration missions. Robotics technologies allow for the execution of tasks that are hazardous for humans, such as spacecraft inspection, satellite servicing, and debris collection. Innovations led by companies like MDA Ltd and Airbus are pushing the boundaries of what is possible in space, enhancing mission efficiency and safety. The integration of robotics is also crucial for the sustainable development of satellite constellations, exemplified by SpaceX's Starlink project. The anticipated advancements in space robotics will support various activities, from the maintenance of operational satellites to the execution of complex tasks on Mars and the Moon, paving the way for more ambitious explorations. 2. Synergies between missions. The interconnectedness of lunar and Martian missions, particularly through projects like Titan Space's Selene mission and the crewed Mars mission, 2032, emphasizes the importance of collaborative technological development and resource utilization. Innovations developed for lunar habitats can inform designs for Martian habitats, allowing for a more efficient use of resources across missions. This synergy not only maximizes the return on investments but also accelerates technological advancements. By sharing knowledge, resources, and expertise, these missions can tackle common challenges in space exploration, ultimately leading to more sustainable and efficient operations. 3. technological innovations. The integration of advanced robotics, artificial intelligence (AI), and innovative propulsion technologies is paramount for enhancing mission efficiency and safety. AI and autonomous systems are set to execute complex tasks in space, reducing risks for human crews and enabling them to concentrate on exploration and research activities. The development of nuclear propulsion systems promises quicker and safer travel to Mars, significantly impacting mission logistics. This technological evolution will not only redefine human capabilities in space exploration but also influence various sectors on Earth, fostering innovations that can lead to broader applications and benefits. 4. Investment and growth projections. Substantial investments from both private sectors and government agencies are fueling growth across the space exploration, telecommunications, and robotics industries. This financial backing is evident in the robust patent activity in robotics across leading nations, indicating a thriving innovation landscape. As companies and nations continue to invest in technologies necessary for the Mars and lunar missions, the resulting advancements are expected to drive exponential growth in related industries. This growth is not only economically significant but also reflective of a broader commitment to advancing human exploration and presence beyond Earth, paving the way for a new era in space exploration. These 4 points encapsulate the critical elements of anticipated growth and innovation in the space sector, highlighting the essential role of robotics mission synergies, technological advancements, and investments in driving the future of space exploration. 1. Apollo Program 1961–1972. The Apollo program was a significant milestone in space exploration, culminating in the first successful crewed moon landing in 1969. This program not only showcased human ingenuity and technological advancement but also had a profound impact on various industries, including telecommunications and robotics. The technologies developed during the Apollo missions, such as advanced computer systems, materials science, and life support systems, laid the groundwork for future innovations in space exploration and many terrestrial applications. The program's success stimulated public interest and investment in space, leading to a booming aerospace sector. 2. Space Shuttle Program 1981–2011. NASA's Space Shuttle program was another pivotal chapter in the history of space exploration. It enabled human spaceflight and the deployment and servicing of satellites, including the Hubble Space Telescope. The shuttle program advanced space robotics, particularly through the development of robotic arms used for satellite deployment and maintenance. It also fostered international collaboration, particularly through the assembly and operation of the International Space Station (ISS), which serves as a platform for scientific research and technological advancement. The program's legacy includes significant advancements in aerospace engineering, telecommunications, and materials science, influencing a wide range of industries. 3. International Space Station 1998–present. The ISS represents a unique collaborative effort among space agencies from multiple countries, including NASA, Roscosmos, ESA, JAXA, and CSA. It serves as a microgravity research laboratory, enabling scientific research across various disciplines, including biology, physics, and astronomy. The ISS has driven innovations in robotics, life support systems, and telecommunications, contributing to advancements in both space exploration and Earth-based technologies. The collaborative nature of the ISS has also strengthened international partnerships in space, paving the way for future missions to the Moon and Mars and demonstrating the potential for shared human endeavors in space exploration. The anticipated 50% growth in the space exploration, telecommunications, and robotics industries by Q4 2032 is expected to be significantly influenced by advancements associated with Mars missions and the rapid evolution of space robotics. Here's a detailed analysis of the future outlook based on current trends and projections. Space robotics, the cornerstone of exploration. The role of space robotics is becoming increasingly crucial in exploration missions. Companies like MDA Ltd and Airbus are pioneering innovations that enable robots to perform tasks that are too hazardous for human astronauts. As robotic capabilities expand, they will facilitate spacecraft inspection, satellite servicing, and debris collection, essential for maintaining the sustainability of space operations. By 2032, we can anticipate that advancements in robotics will allow for autonomous systems in space, such as AI-powered robots that can conduct geological surveys on Mars or deploy satellites in orbit without human intervention. This evolution will not only enhance mission efficiency but will also reduce the risks associated with human spaceflight. Synergies between lunar and Martian missions. The interconnectedness of lunar and Martian missions, exemplified by initiatives like Titan Space's Selene mission and the crewed Mars mission, 2032, will drive technological innovation. Lessons learned from lunar missions will inform Martian exploration strategies, particularly in habitat construction and resource utilization. For example, technologies developed for lunar habitats may be adapted for Mars, leveraging local resources to minimize the need for Earth-based supplies. Investment trends and market growth. A surge in investment from both private sectors and government agencies is fueling growth in these industries. The increasing number of patent applications in space robotics indicates a vibrant innovation landscape. By 2032, we can expect venture capital and governmental support to catalyze advancements in technologies essential for Mars missions, such as nuclear propulsion and in situ resource utilization (ISRU) systems. This influx of capital will not only enhance technological capabilities but will also drive economic growth across related sectors, including telecommunications and robotics, as companies seek to develop and commercialize new technologies. Telecommunications evolution. The growth of telecommunications will be closely tied to advancements in space exploration. As missions to Mars and beyond become more frequent, the demand for robust communication networks will rise. Innovations in satellite technology, such as those being developed for SpaceX's Starlink, will play a critical role in ensuring continuous connectivity for both crewed and robotic missions. By 2032, we can expect a network of satellites capable of providing high-speed internet across large swaths of the Earth and potentially serving as communication relays for deep space missions, transforming how data is transmitted and received in space exploration. Robotics and AI integration. The integration of robotics with artificial intelligence will be pivotal in enhancing mission efficiency and safety. Autonomous robots will be designed to execute complex tasks in space, from constructing habitats on Mars to maintaining satellite constellations. By employing advanced AI algorithms, these systems will optimize resource use and enhance the overall success of missions. By 2032, we should see fully autonomous robots on Mars capable of performing scientific research, habitat construction, and even emergency repairs, significantly reducing the workload and risks for human astronauts. Future scenarios and applications. The future scenarios envisioned for space robotics will likely include satellite servicing. The development of robots capable of repairing and maintaining satellites will prolong their operational lifespans and reduce costs associated with satellite replacement. Resource extraction. With advances in robotics, asteroid mining could become a reality, providing vital resources for further space exploration and potentially addressing resource shortages on Earth. Space tourism and colonization. Robotics will facilitate the construction and maintenance of habitats for space tourism and potential colonization efforts. Robots will prepare landing sites and construct habitats, enabling a sustainable human presence on the Moon and Mars. Conclusion. The anticipated 50% growth in the space exploration, telecommunications, and robotics industries by Q4 2032 represents a transformative phase in human space exploration. Driven by advancements in robotics, interlinked lunar and Martian missions, and substantial investments, these industries will redefine our capabilities in space. As we approach 2032, the synergy between technological innovations and collaborative efforts in space exploration will not only enhance our understanding of other celestial bodies but also pave the way for sustainable human existence beyond Earth. The next decade promises to be a pivotal period for the space industry, with the potential to unlock unprecedented opportunities and challenges in our quest to explore the cosmos.